Hello, and welcome to 60 Seconds to Code, where I show you how to code in 60 seconds or less. Today is going to be part 4, or the final part, of a multi-part video series, in which I've been showing you how to use Lex, Lambda, CloudFront, and other AWS technologies to create an artificial intelligence chatbot. Now, the chatbot that we created in the previous videos was a jokes and facts chatbot, and we were supporting two intents. One was a jokes intent, the other was a facts intent. And then after first we created the chatbot, then we connected the chatbot to a Lambda function so that we could connect it to an API endpoint. Then I showed you how to use Terraform to deploy all your static content, which included the front end of your Lex chatbot, onto a CloudFront distribution, and host it using an S3 bucket and secure it with the ACM certificates and connect it to a Route 53 domain. All of that was that was the first 3 videos of this multi-part video series. Today's the 4th video, in which I'm going to show you how to use Cognito. Because in the previous videos, now I'm going to tell you why Cognito is necessary. In the previous videos, the front end of the static site that we deployed, which included a chat interface, and you were able to get chat jokes and facts from that chatbot as well. But that was actually a dummy chatbot using just using JavaScript. It actually was not connected to the chatbot that we had developed in part 1 of the video series, which was the actual Lexbot. So today what we're going to do is we're actually going to connect our front end, and in this case, which is our JavaScript front end that we developed and we actually started hosting using Terraform, using CloudFront and S3 and all that. Today we're going to connect that front end to our AWS Lexbot. Now, in order to connect that Lexbot, what we need is a service that Amazon provides. It's an AWS service that is called AWS Cognito. And what Cognito is, it's an identity management system. What do I mean by that? Using Cognito, you can create or give access to users to AWS services. Now, that might be a little bit broad, so let me get a little bit more specific. Let's assume, for argument's sake, that you want to develop an application. In our case, the application that we're developing, or the application that we developed, is a front end of a chat interface, and we want users to be able to interact with our chatbot. What do I mean by that? We want them to be able to interact with our chatbot. We want them to be able to talk to the chatbot, receive responses from the chatbot, etc. Or perhaps we developed a file sharing or a file uploading service, and basically we want the users to be able to upload documents or upload content to an S3 bucket and download content from an S3 bucket. And that's our application interface, and we would like to be able to do that. And we basically would like the user to be able to interact with any of the AWS services. Now remember, these AWS services, what do they need? They need, in order for you to be able to interact with them, they need credentials. With AWS, you need what is called an access key ID and a secret access key pair. And those credentials are what's needed in order for you to be able to interact with any AWS any AWS-based API service, whether it's the API for Lex, whether it's the API for S3, whether it's the API for EC2, whether it's the API for ECS. Any API, if you want to interact with it, you need credentials. Now, what's the purpose of Cognito? With Cognito, you can exchange, you can exchange for temporary credentials, so that using those temporary credentials, you can send API requests to the AWS API endpoints, and you will be able to interact with AWS services. With Cognito, what you can do is you can exchange 2 types of credentials. One is called an authenticated credential, and the other is called an unauthenticated credential. Today we're going to be working with the unauthenticated case, but the authenticated case might be, for example, a user logs into a website using either federated identity or some kind of social identity such as Facebook or Google or whatnot. And basically, now that they're logged into your website, or that they've logged into your application, they would like to be able to upload content. And basically, the way that you've designed it, or the application is written, is that you need to upload that content to an S3 bucket. Well, then how do you do that? The way you do it is you exchange that user's federated identity credentials or social identity credentials such as Google, Facebook, Twitter, whatnot, for temporary credentials, and using those temporary credentials, you assign those temporary credentials to that user, and any of the user's requests to either upload to S3 bucket or view from S3 bucket are signed with those temporary credentials, and then the user is able to interact with those AWS services. So after that lengthy preface about Cognito, right, what we're going to do today is we're going to go to the AWS console excuse me, and we're going to first create our identity pool, if this one lets me. So let's go ahead and do that. Oh, it's been a long day. Let's go ahead and get this going. So let's go to console, and I think I'm already logged in. Yep, I am already logged in. So if you go to any of the services, you will find Cognito under identity and access. Actually, not identity and access management. Just go to services and you just type Cognito and you'll find it. I don't exactly know which category you will find Cognito under, but if you just type Cognito in the search, you will find it. So let's go ahead and go to click on Amazon Cognito, and what we're looking for is actually an identity pool. Now, in your case, if let's assume for argument's sake your application requires for your users to be, you want your application to have managed user IDs and passwords and etc., you need to create what is called a user pool. But in our case, the chat application that we're developing is completely anonymous. Anybody will be able to interact with our chatbot, and our chatbot is going to be published to, obviously using CloudFront and S3 to a public domain. In our case, last time we used my personal domain, which was codislife.de. So today we're going to be interacting with Amazon Cognito using managed identity pools. Now, what's the purpose of an identity pool? And with an identity pool, just like I said a second ago, you can create you can exchange for two types of credentials, one for authenticated users and one for unauthenticated users. So let's go ahead and start to create an identity pool. So I have already created a couple. I'm just going to say create a brand new identity pool, and I'm going to call this Let's Chat Video Demo ID Pool. Right, that's the name of the identity pool. And in my case, I'm not just going to allow access to unauthenticated identities. I'm sorry, just authenticated identities. But I'm going to allow us access to unauthenticated identities. I'm not going to worry about the authentication stuff because just like I said just a second ago, there are many authentication providers with which you can configure your Cognito identity pool. So which include Amazon, Apple, Facebook, Google, Twitter, OpenID, SAML, custom, like anything you can think of, you can integrate with Cognito. But in our case, the only thing we're really interested in is an unauthenticated identity, because it's going to be a public website and anybody on the public internet will be able to interact with our chatbot. So let's go ahead and create that. And let's go ahead and click create pool. And we will now be presented with basically the IAM role that this identity pool will be able to assume as a result of this. Now, remember, in order to interact with any AWS service, you can assign a role to the user, and the user will be able to assume, or the principal in this case will be able to assume a role. And now we have what is called we're as a result of this the wizard that we're creating, our identity pool, it's telling us that it will create for us two roles. Number one, an IAM role for our authenticated identities, and number two, an IAM role for our unauthenticated identities. Now, for our purpose, I will need this role name in just a second, because right now the role will not be able to do much. It won't be able to do anything. It will not have any permissions. I will have to go to identity and access management and give this role permissions to be able to interact with our Laxbot. So let's go ahead and copy onto our clipboard the name of this role and click. Basically, when we click allow, it will create these two these two IAM roles. So let's go ahead and click allow, and there it create. Now what it did was, as a result of this creation of this Cognito identity pool, it created two roles, one an unauthenticated role and the other an authenticated role. So let's go ahead and go find that role in an identity and access management. You know what, let me go ahead and open and duplicate this so that we can get this in a new tab. There we go. Let's go identity and access management, find our roles and find the role that we just created, and there it is. Now if we go to this role, this Cognito Lex Chat Video Demo Identity Pool Unauthenticated role, you'll find that this does not have the ability to do anything. You will see that it has pretty much no policy or no abilities attached to it, okay, other than some basic Cognito sync, which is required in order for this this role to work. Basically this role really isn't able to do anything. Now this role, let's assume for argument's sake that you wanted your unauthenticated users, I don't know who would want to do that, but if you wanted your unauthenticated users to be able to upload to an S3 bucket, you want them to be able to interact with either EC2 or some other AWS API. This is where you would give them permissions to be able to interact with your AWS services, right? So the first thing that we need to do is we need to add permissions to this identity pool, and the permissions this identity pool is going to need, this unauth identity pool role is going to need, sorry, not pool role, is going to need, is the ability to run AWS Lexbots. We published a Lexbot that we called Jokes and Facts Bot, and we published an alias, the dev alias to it last time, if you remember, we tried with it in the last video. Today, for this unauthenticated role, it must be able to interact with Lexbots. So let's go ahead and add permissions and create attach policy. And let's go ahead and let's find Lex runtime or Lex run bots only permission. What this will allow this to do, and if you want, you can read the policy statements. What this will allow this unauthenticated role to do is it will be able to post text, post session, get session, delete session, recognize text, all these, basically the basic Lexbot permissions that you need in order to be able to interact with an AWS Lexbot. However, if you take a look at the Lexbots run only, notice the resource is marked with an asterisk. The reason this resource is marked with an asterisk is that if you attach this particular policy, the unauthenticated role will be able to interact with all of your Lexbots, whether it be a Lexbot that is an unauthenticated Lexbot or an authenticated Lexbot. Probably in your case you wouldn't want to do that. So let's go ahead and click cancel, and let me show you how to actually mitigate that. I'm going to go to my I'm going to provide you a link to all the code in the description below. I'll upload this to my GitHub account, and you will find within the repository a package, not JSON file, a policy JSON file. And in this policy JSON file, what we're going to do is we're going to create, using this policy JSON file, we're going to create an inline policy. So under add permissions, when we get to IAM role, we're going to click add permissions, and we're going to click create inline policy. And then using the JSON editor, I'm going to attach that policy. Now, what is this policy statement doing? This policy statement, this IAM policy, is giving the effect of allow to all the following Lex actions, whether it's the post content, post session, put session, delete session, etc. And what it needs, or in our case, what we are trying to do is we're trying to restrict it to a specific bot or even a specific bot alias, right? So if you remember in the managed policy, which was the Lex run bot policy, the managed policy had an asterisk for the resource, but in our case, what we're providing is we have to provide the resource for the region, in this case it's going to US East 1, and then in this case your account number, whatever that account number might be, and then the bot name, and then the alias name. If you want, you can find this particular policy, and you'll find this policy in the Git repository that I have a link to in the description below. So the only thing you have to change is, just like I changed just a second ago, You have to change the region. Because Lex is a regional service, your bot is going to be published to a particular region. You have to change this number, this 1234 number that you see on your screen, to your particular account number. The bot is going to remain the same. The bot name is going to be your bot name, and the bot alias is going to be the alias for your particular bot, right? And when you do that, then when you attach this inline policy to this particular unauthenticated role, then this unauthenticated role will only be able to interact with your chatbot, and even your chatbot with that specific alias, nothing else. And you want it locked down as much as possible, but for the purposes of this demo, I'm not going to do that. I'm just going to say attach a policy, and just going to say Lex run, and attach the Lex runtime policy, and there we go. We have attached the Lex run bot only policy, and now using this policy, any AWS Lex bots that are within my account, whoever I provide this this Cognito user pool, and this user pool is then able to assume this particular role, they will be able to run all my Lex bots. So that's it on the permission side. We are done with IAM, so I'm going to close that button. I'm sorry, that tab. Now let's go back to the Cognito identity pool. Now, for the Cognito identity pool, what you're going to need is the identity pool ID of the identity pool that you just created. Now, in my case, I will probably delete my these identity pools after I'm done. So if you try to use any of my stuff, it definitely won't work, because I don't want you interacting with my chatbots. I don't want any security hole left in my account. But obviously, once you create this Cognito identity pool, you go back to Cognito. You will find this the identity pool ID in your identity pool sample code. So go ahead, copy it onto your clipboard, and we're going to go back to our simpletat.js file, and we're going to for those of you who don't know, this was the the front end that we created. Actually, we didn't create it. We found online for a very simple interactive chat application. So now what we need to do is we now need to configure this whole thing. Now, I'm not going to go into the details of how I went about configuring. I created an extremely minimalistic configuration such that I'll be able to interact with my AWS LexBot. But if you want, you can read the details of it, and the sample code that I used to actually write this can be found in the GitHub repository that I have linked up here. So you will find that in line 138 of the sampletat.js file in the Git repository. Now, the very first thing that you need to initialize on line 139 of the sampletat.js file, and again, these files, the purpose of each of these files, bootstrap min, sample chat, index.html, all of that, you will find in one of my previous videos. So this is part 4 of the video series. Obviously, you have to have watched the first 3 videos in order to understand what the purpose of all this is. But the very first thing that I'm going to do is, this is the jQuery function, which is basically akin to the document ready function. I need to configure an AWS region. In this case, by the way, you should also know that I have included the AWS SDK as part of the script source, and now the AWS SDK, which is the JavaScript SDK, is available to me, and therefore I'm able to declare and use. Close this guy. And therefore I'm able to declare and use AWS configurations. The very first thing that I need to configure as part of this AWS configuration is the region, and because my bot is in the US East 1, I've hard-coded the US East 1 region. And then, as part of the credentials, I need to provide AWS configuration credentials. And I'm going to be using Cognito identity credentials. And this is where I provide the identity pool ID, or the ID pool ID, what a mouthful, of the identity pool that I just created. So I'm going to paste that in off of my clipboard and put that in. And now my configuration is done. All of this is now ready to interact with my chatbot using this credential this Cognito credential. Now, for the uninitiated, if you would like, I can go into a little bit of detail of the JavaScript. I would recommend you go in through the details of how I am interacting with the AWS API. You can you can take a look at some of my sample code that I've provided here, some of the sample code in the GitHub repository that I've linked in line 138. And I would recommend you go through each line by line, but I will quickly go over what I'm doing here. What I'm doing is, as part of the document ready function, the very first thing I'm doing through all of this is configuring the AWS region and credentials. And then I'm providing some basic parameters that the AWS Lex runtime service connection needs. And I'm putting them in this my params parameter, or which is basically a JavaScript object. And within that JavaScript object, I'm specifying the alias of the bot that I want to interact with, the name of the bot that I want to interact with. And notice, if you remember, this ID pool ID is able to interact with all of my chatbots. If I wanted to restrict it specifically to a single chatbot, then I would have to attach an inline policy. And within that inline policy, I would specify my bot name as Jokes and Fat Bot. And don't spray it. Jokes and Facts Bot, and the alias being the dev alias. But in my case, I'm not going to do that. I'm going to allow it to interact with all of my chatbots. But in this case, in order for my Lex runtime service to be able to interact with my Lex bot, it needs to know the bot alias as well as the bot name that it needs to interact with. So if you want, you can read the details of how all this is configured and find out how the Cognito identity credentials are configured, and how these parameters are configured and passed to Lex using the Lex runtime service, and you can read AWS documentation about it. Now, in our case, after that, we are going to display a very initial simple message that, hey, welcome to chat. You can say, tell me a joke or tell me a fact. This basically is going to be the initial response that we're going to give to the user, and then the user can interact with our chatbot. Now, the rest of it is pretty much standard. It's the same code. The user will then be able to type into my chatbot window, or press enter and click the send button, and then they will be able to interact with my chatbot. Now, when they do that, the next function call that we're going to make is going to be to the make Ajax call function, and we're going to find this pass this my parameters object to that function call. So let's go ahead and go to the definition. Let's go to the definition of that make Ajax call, and we're passing in the parameters. And the very first thing we're doing is we're getting from because the user is interacting with our chatbot, the message that they want to send to our Lex service, we're going to store it in a message variable, and then we're going to blank out the text box, the chat window, and then we're going to enter that this is the message that the user displayed onto the screen, and then the part of the parameters object that we need now. That parameters object needs a property called input text, and that input text needs to contain the message that the user wants to send. And because we captured it from the input text box, we are telling it, hey, use the message that was provided to you from this particular input box, and set that as the input text value of the parameters object. And once you're done doing that, now it's time to make the API call. Now, the next the API call that we need to make is to our Lex runtime service, and that is what we do here. We first do a try catch. Now, the reason this is put in a try catch is because we want to make sure that anything fails, we do get a graceful error handling instead of some weird console errors. So we first do a try catch. Now, it will asynchronously make a call to async get next utterance function, and we are passing the parameters object that we've built, and that input text value for the message is being sent into the parameter object to the async get next utterance function. Now, if you remember in the previous videos, that async get next utterance function was actually making a dummy call to some dad joke and facts API call. It was just a simple get or simple get API calls to those, but I have basically commented that old function out, and I've created a new asynchronous getNextUtterance function. And this asynchronous getNextUtterance function accepts the parameters object, and it returns a new promise. And that's why it's an asynchronous function. It will wait for this promise to be fulfilled. And this is when it creates a Lex runtime service. And this new Lex runtime service is then we use it to make a call to the post text function, and we pass the parameters object. This parameters object we built all the way down here. In the my parameters object, we set the bot alias and the bot name, the user ID, and then using the make ajax call function, we then set the parameters input text value, and then we made a call to the asynchronous getNextUtterance function. So let's go to the definition. What it will do is, using the Lex runtime service, it will perform a post text operation, and this parameters object is going to contain the name of the dev, the name of the bot, the alias of the bot, and what the user is trying to say to the bot. And as a result, what is expected as a result. If it errors out, we will console log the error stack. Obviously, this is for dev and demo purposes only. Don't do that in your production environments. Be mindful of that. But whoops. This promise then accepts two different functions: the accept or the resolved functions, and the rejected function. In this case, if the function errors out, we will console log the error, and we will make a call to the rejected function, and the rejected function we will pass the error and the error message. Otherwise, we will make a call to the resolved function, and the resolved function will be passed the data. And that's pretty much it when it comes to the async getNextUtterance. This is where the magic is happening. This is where we are building the Lex runtime service and making a call to the Lex runtime service, and we're returning the promise. So let's go ahead and go back to getNextUtterance. So right, this is the try catch statement that we were on. After this call succeeds, because the call is going to succeed, it will make a call to the onFulfilled function. Let's go ahead and go to the definition of the onFulfilled function. The onFulfilled function will say console.log that the response was received, and it will display a left message, which is basically what we will see on the left hand side. A chat bubble will appear that this is the response that that AWS sent back. And if there was an error, it will make a call to the onRejected function, and it will display a simple error message on the left hand side saying an error has occurred, and it would actually print the stringified error stack onto the JavaScript console. And that is it for all of this. So, but now, one thing that I'm not going to do today is I'm not going to upload this, the simpletat.js file and upload it to or host it using CloudFront and connect it to Route 53 and all that. That was in part 3 of this video series. That's part of your homework. Go ahead and make these updates, see what my code is doing, and actually, connect it to your, using Terraform, connect it to your custom Route 53 domain, and, and part 3 of this video, which was a lengthy video. Go ahead and do that. Go ahead, update the simplechat.js file and connect it to your CloudFront distribution, and secure it with the ACM certificate, and backend host it with an S3 bucket and all that. You can find all the details of how to do that in part 3 of this video series. But today I'm not going to do that. Today all I'm going to do is I'm going to run this locally. So I'm just going to do an npm start locally, make sure the simplechat.js file is saved, and click npm start and hit enter. So let's go ahead and go to this. Go ahead and go to this in an incognito window, and let's start interacting with our chatbot. Now notice this is just hosted on my local machine. The only difference is that my chatbot is right now hosted on my local machine. If you follow the previous video in which I go into lengthy detail about how to host a static site and configure it using Terraform, it will be hosted in a publicly hosted domain. That'll be the only difference. In this case, I'm hosting it locally. So let's go ahead and start interacting with my chatbot and say, tell me a fact. Let's go ahead and do that. And send. Let's see what it says. And there is a fact. let's go ahead and ask it to tell me a joke. And say what type of joke. Now remember, in the previous videos, the very first video, we were supporting two types of jokes: dad jokes and Chuck Norris jokes. So I'm just gonna ask for a dad joke and hit enter and say, okay, what does a female snake use for support? A cobra. That's actually that's actually pretty good. Let's try telling it tell me a dad joke, and let's see what it comes with, because in this case we're passing the value for, or the slot that we're looking for is the dad jokes, the joke type. In this case we're asking for a dad joke, so let's go ahead. What's Forrest Gump's Facebook password? 1Forrest1. So this one I've heard before, but this was freaking hilarious. Okay. And excuse me, I'm a child. And that's it for today. We have what we did today was we created a Cognito identity pool. We configured it so that the role for that Cognito identity pool is able to interact with our Lexbot. And we finally went ahead and configured that identity pool in our code. And then we interacted with the code using our local host. Now for your homework, don't forget to make, number one, go through my code and see what I'm doing there. And finally, if you feel up to it, watch my Terraform video, how to deploy a static site and host it, using a CloudFront distribution and all that, and how to connect to the Route 52 domain. Watch that video too, and connect and host your chatbot on a public domain. And that will give you an end-to-end feel of what it takes to, number one, develop a Lex chatbot, because that was the very first thing we did in the part one of this video series. We developed a chatbot, we developed intents and utterances, we created a Lambda function backing that chatbot, and we connected that chatbot to that Lambda function, and then we interacted with that chatbot. In part two of that video series, we what did we do? I don't remember the exact sequence, but then we created I believe it was a front end of the chatbot, and in part three, I believe it was the Terraform video in which we connected our we hosted our front end using Terraform, and we configured our entire Terraform stack, and we hosted that front end. In this case, this front end that you see on your screen, using Terraform, using Route 53 and CloudFront and S3. And today we came full circle, and we connected our front end through to Cognito. And now if you host this front end using the previous video on a CloudFront distribution and connected to a Route 53 domain, users will be able to interact with your chatbot. And this takes you full circle. You developed chatbot, you created a user interface for it, you connected it to, and you deployed the stack using infrastructure as code using Terraform, and today we connected it using Cognito, and now we are interacting with our chatbot. That's it for today. Thank you very much for watching. Until next time, I will see you later, and find the links that you're looking for in the description below for the Git repo, as well as any other links that are appropriate. Thank you, everyone. Until next time, talk to you later.